I don't see it. Oh yeah, there it is. Okay, now we got
Yeah,
it.
yeah, cool. Yeah, now we've got an insurance on the recording. So yeah, today I will give a very quick walkthrough on this Whisky library. So this Whisky library is actually just a Cardano SDK in Rust. We have implemented a lot of things pretty much identical to Mesh. So later I will also give a demo on everything. So before I jumping into it, I just very quickly walk through what kind of public resources we have on finding the examples and documentation. So first thing first is this Endamio course. Literally is a kind of a sum up on some endpoints that I want to highlight in these lessons about how to build a datum or anything. So this is a pretty good place to really get started. But if you want to understand a bit more about the endpoints or details, we have two documentation. Indeed, the first one, this hosted documentation is pretty much oh, it's not. Yeah, we've got one hosted documentation here, and there's also another Git book here. So for the Git book, the whisky.cdan.io, this one is pretty much very identical to the Endamio lesson, but probably going forward, I will maintain the Endamio instance rather than this kind of documentation. And another documentation we have is the inline documentation. This is a generated documentation. So basically it covers every endpoints we're using in the library and is probably up to date. So yeah, so let's get into about a little bit deeper into what's key here. Let me do some. Yeah, I have my face. Yeah. Yep. So Whisky, this library, it has two different layers. So the first layer is a name that we didn't give it a thought. Indeed, it's called Cdan CSL Rust. This is basically a wrapper across around the Cardano-serialization library from Amerigo, and it helped to tackle this all of the lower level stuff like transaction serialization and resolve something and also exporting a lot of types. So this library we will also package into WebAssembly for Mesh to use. So right now, since Mesh version 1.6 is indeed we are building a JSON from TypeScript and then send the JSON to this WebAssembly library, and then we serialize the Cardano transaction. So literally, this is a layer that we handle most of the lower level stuff. So if you use the Rust code base, in most of the time, you don't have to deal with this unless you're trying to find some utility function and so forth. And Whisky is a library that we package in Rust that are exporting a lot of more higher level functions and utilities. So why we have to split these two packages is that not every infrastructure that we are using is natively supported by WebAssembly. So for some more advanced features like off-node transaction evaluation, we are using TS pipes UPLC to do it. However, that package is not directly compilable to WebAssembly. So if we want to have one package exported to the TypeScript kind of code base, we have to split it out. And also there are some more higher level features that we didn't implement yet, like the fetcher or like different provider of evaluation. We didn't really implement it yet, but this is also another reason why we have to do it in Whisky, because those are some packages, for example, the async function, this kind of thing in Rust, that is not directly compilable to TypeScript. So this is some of the background around why we have to split it into two packages. So for today, I cover how to use it in Rust. Actually, it may sound a little bit scary to write Rust to build a Cardano transaction, but indeed it's not really that difficult. And I will show a little bit of the code snippet. So how to use that feature, pretty much I've explained it. And how to use it is basically just in your library, you just use cargo add, and then you could initialize the package. So this is a shape of what a kind of first transaction looks like. It's pretty much very similar to Mesh. And yeah, the syntax we still keeping right now identical to where we start to build it, but we are gradually kind of renaming the code base to make it less confusing because you're using Whisky, but there's mesh. Probably there will be some mesh kind of wording in the more lower level or inner part. But going forward, if we build the higher level function, we will try to make it more easily understandable as possible, like maybe using Whisky or just TS builder and so forth. So just jump directly into how to build a simple transaction. So this is how you could expect from Whisky is that first of all, we have the TS builder instance. So for the TS builder instance, basically is identical to what we have in Mesh. You could just still look into the Mesh documentation to look into how each endpoint works. We are actually using exactly the same kind of API naming conventions. So for example, here you see the TS out in Mesh documentation. And here we use the TS out here. And also for the type, we are building the identical type from MeshJS to in Rust. For a lot of the types, if possible, we will just directly inherit the same. So this is some helper function building the access. But if we maybe just jump into here a bit to see what this is like in the access. Yep. So this is a very familiar type that you see kind of day-to-day in Mesh. Just we try to build whatever as identical as possible to the Mesh type. However, we have added in a lot of different utility functions in Rust. So this is our kind of design kind of principle or philosophy. And you can see literally it's very identical. Like change address, this is a change address everyone knows. And select UTXO from this input selections that we're performing. And so far, we only have one selection algorithm that we really implement a lot yet, but this is kind of a vanilla function linear search that probably good for most of the use cases, unless you have a extremely complicated wallet. So there's a threshold. And in the TS builder in Whisky is also the same as Mesh, where we have two complete functions. First complete function is what we call complete sync. It's the same as somewhere here I live. For the complete sync is the complete function to build the transaction without any dependency. Dependencies means some providers that we are providing to the TS builder, like fetcher, evaluators, and also submitters. But probably in transaction building is mostly fetcher and evaluators. So for now, we didn't really implement the fetcher yet. But for evaluator, we have one inbuilt transaction evaluation from UPLC, which we don't have to provide any providers. So here is a super simple example about how to build a send lovely transactions. Like you specify the TS out addresses and then perform the UTXO selection, and then you do the complete, and that's it. So far here, is there any questions from the audience?
It's marvelous, guys. Like how much low-level support this gives while taking care of the boilerplate. I really love how complete works in Mesh, and seeing that it's here is really awesome.
Yeah,
Very
actually, for a later part, I will do a demo on how to write the bridge across Rust and, for example, TypeScript Next.js application. This is a better kind of demonstration into how interconnected it could be. Yeah.
Yeah. So you mentioned about like not needing a provider for evaluation. So that wasn't the case for Mesh, right? And you're saying that it's due to WebAssembly.
Yep. Exactly.
So yeah, okay. So if I build a transaction using Whisky, then in my machine, like in my local machine client, the evaluation happens, and you're using this TX pipes UPLC.
Yep. So to give you a little bit of the context, can jump into the source code a little bit. So in TS Builder here, we have this big guy here, this transaction evaluation. So this is somewhere we use the UPLC kind of infrastructure to perform the evaluation phase 2. Phase 2 means checking the script execution unit and whether the script is valid or not. TS Pipe has implemented the whole Cardano node kind of VM in Rust codebase that we could directly use it. But some small part of their package is not WebAssembly compilable, so we cannot compile it to TypeScript for Mesh SDKs right now to directly use it. But I think it is some things that could be solved by some more R&D time. But it comes to the priority. Yeah, it's a little bit hacky into the lower level thing, like forking the UPLC library, erasing some of the libraries or dependencies that they're using, this kind of thing. But here's kind of the magic, like we just directly call the functions, perform the kind of type conversion from the mesh type or Whisky type into the Palace type, which is the lower level types that used by all the TS Pipe infrastructure. Yeah, and at the complete function, is it? Yeah. Complete is actually here. Yeah, at the complete function here, we will perform the evaluation. So for right now, we will default the evaluator to be the off-node evaluator. But indeed, we have also implemented Maestro evaluator for testing. So if you like to use Maestro, and yeah, you just directly try to plug in the evaluator by initializing the TS Builder with a provided, I think it's here. Yeah, there's a TS Builder param. You could provide your evaluators in. So you could initialize a Maestro provider, and this Maestro provider has the evaluation implemented. So yeah, you can still use it. And yeah, up to your choice. So normally if you use the hosted node service like Maestro, is a little bit more reliable because we all know that implementing a whole VM in Rust is not that straightforward. And sometimes we catch a little bit of inaccuracy in the X unit that return it to us. So if we want to have more accurate evaluation, it's also okay to plug providers. But if you do not provide that, we will default using this UPLC evaluation. Yeah. So I think I could give a super quick walkthrough on this lesson because purely speaking, doesn't really, yeah, make good memories on how everything's worked. So yeah, here it explains a little bit onto how to lock in fund by providing datum. And this is something that I have highlighted in this Endamio lesson, is that in Whisky, we are going to provide the datum in this format. Like we build one additional type, which is called W data, the acronym Whisky data, that you can specify whether this string is in form of JSON string or CBOR string. It's just for at the completion level that try to let our code base to understand where your kind of datum come from. So yeah, literally it's also very handy because for those endpoints, it's pretty much exactly the same endpoints that you are facing in MeshJS. So perhaps I don't have to spend much time here. So when it comes to unlocking, it's also the same, like exactly the same 5 kind of endpoints that we are using, like specifying the script version, TSN, and then datum source, and then redeemer source, and then script source. These are the 5 identical flags that we need for unlocking funds from scripts. And it also in the documentation here, we also supplement a little bit about some details and what you want to do with the script unlocks. For example, if you want to do script validation, you have to provide collateral is highlighted here. And also when it comes to redeemer, this is a type similar to the datum or data type that we have this Whisky redeemers. also as a wrapper to allow you to input whether the string provider is in CBOR or JSON. And here we intentionally provide a zero budget because it is to demonstrate how the off-node transaction evaluation could work to help you to directly update the execution unit without you to supplying it. And if you want to use it, you have to end the case building by complete, but not complete sync. Because if you use complete sync, it's by default ignoring all the evaluation, updating, and fetching. So if you want to use it, you have to call with the complete. And with complete, it is an async function. So in Rust, it is somewhat similar to JavaScript, some syntactic sugar to have the dot await to get rid of the promise kind of concept in TypeScript. So there's a full demonstration, pretty much very identical to what we have in Mesh. Maintain is the same, so probably I don't spend quite a lot of time here. So the same, the fall flat script version, and then what you meant, and then script source, and then redeemer source. Yeah, if you want to build a complex transaction like unlocking from 1 and minting 2 token, just same as Mesh, you just have to chain everything together. The 5 flag from unlocking, the 4 flag from minting, another 4 flag from minting. This is a perfectly working transactions. So yeah, just let me just directly jump into the demonstration. It might be much more interesting. So let me just quickly point into where the resources exist. So in the Whisky library, this is a repository. We have the package directory. Inside the package, there's one folder called example. So this is where we serving all of the example here. And because it may feel a little bit remote if you write the Rust codebase for Cardano DApps. So that's why as part of the example, I've also built this web example. It's literally just me running the nps MeshJS, and then I just choosing the Next.js template and then build some examples here. So yep. So for convenient, I built this shell script in Whisky repo to address in use. This is it. Oh, there's something running here. Let me just kill the process. Okay. Yep. So this is let us take a look. What is the example like? Is basically just a very simple demo demonstrating how to send Lovelace, love fun assets. So let's firstly take a look into what are the codes that we have been written. So in this Whisky example, this is a demonstration on how to build a web server in Rust with the one of the simplest web server kind of package in Rust, which is the Atlas Web. And we just host the 4 post request functions. The 4 post request function pointing into this send Lovelace, love fun, and love fun can also mint tokens. So let's take a look into this love fun. So for this log fun, we're expecting the request here is to having the script address, data, my address, and inputs, and then pointing into this log fun function. This is literally I remember it's exactly the same functions that you've seen in the Amio lecture. So I put in the code base, put it in the code base here. And then we could see there's 4 different flags here in the 3 different flags. And yeah, I jumped a little bit. So firstly, let's chat the send Lovelace. These 3 kind of inputs, and then we have the request having to expecting exactly the same kind of function name. But how can we communicate it with type? Actually simple. Like here we could see the type here I use the kind of serialization package in Rust. So the result is that we could directly look into the send Lovelace here. Recipient address, my address, inputs. Let's do a compare and contrast here. So here we're accepting the recipient address, my address, and input. So what's cool about Whisky is that we are actually building with the same type of MeshJS. So what's the implication? Like here, you can see how we could obtain the inputs is by using wallet.getUTXO. This is kind of our familiar function from MeshJS to get the input UTXO. And then we have this UTXO and the inputs. So, yeah, we have this input here, and then we provide it to here, and using with our kind of package is actually exactly in the same type as Mesh. So what we could do is just get TXO and apply it into a post request, and then we could cite the transaction. We could just try that. Yep. So this is how we could just send a kind of send Lovelace transaction. It's just as easy as this. So far up to here, any questions?
Yeah, that was really beautiful how you just fetch using the mesh react UTXOs and then just pass it directly without any much thought.
Yeah. Yep. So don't have to do any of the kind of round trip parsing and any other things. So just, yeah, as simple as this. So yeah, so this is our first transaction demo. Let's try go into the second. The second is the log fund transaction. So we could also take a look into how log funds work. Script address is the address of the script. From here, we have used some of the MeshJS utility functions from here, the serialization Plutus script, and then we could get the address. And these, yeah, also for this demo, I could give a bit of the background on what the smart contract is. Is it indeed just taken from the MeshJS repository that we have a hello world script. For this hello world script, we're expecting people to put in the owner pub key hash into datum. And then people will provide a redeemer. So we will do two very simple checking. So first one is whether the owner has signed the transaction by checking the required signer. Second is to check whether the redeemer equals to hello world. So that's why this is a hello world spending transaction. So from here, so because we are checking against the datum with whether we have the signature of it. So for the log fund here, we have some very simple data processing as we're getting the wallet at change address, and I just get the pub key hash. And with this key, I provided to datum. So this is a way that we could build the datum string, and this is also exactly the same format that is expected from the Rust code base. So here we have let's take a look into what this is expecting. Script address, it is the address put into the ts out. For here, we could just provide an empty array or a list, just like what we do in Mesh. If we provide the empty array, it will just directly assuming it is attaching the mean UTXO. So we don't have to really do the calculation. Here, I use the inline datum, and since I'm building the JSON type, for detail about how to build a JSON type in Mesh, there's also hosted documentation here. There's a JSON data. We are literally just building according to this these functions. So from here, I build a JSON datum, attach it, change address, UTXO selection, and yeah, as simple as this. And then let's see. When I try to log fun, yeah, it's just as straightforward as this. So right now we have locked the fund in the smart contract, and then we want to unlock it. So here I perform some very simple. Yeah, is there any question you want to ask?
Yeah, before jumping to the this utils that you have been using from the mesh site, does Whisky provided natively in REST if we want to do it in the backend, like deserialized
Yeah,
address, things like that.
yeah. It's there's also still the deserialized address function in Whisky if you want to use it. There's for most of the utility is living inside this CSS Rust, but everything is exported through Whisky. So if you just add Whisky, you could also get everything like this. So here we have the deserialized address is literally identical to this one. Just we are using the same functions. So if you want to directly use in the Rust code base, it's also supported. But for this utility function right now is less well documented so far. So maybe you have to dig a little bit into this folder to see what's existing here. Yep. So let's quickly move on to the unlock fund. The unlock fund this here. So for unlock fund, it's a little bit more complex than the simple locking fund because you have to provide a lot of smart contract validation thing. And from here, we also try this SUnit update by pipe. So one thing that I have to highlight is that in order for the UPLC redeemer evaluation happens off node, you have to provide every input informations. Like what does it mean by every input information? Is that, for example, here, if you do inline datum, you're expecting at the transaction submission, the node will find the datum on the node and then help you to evaluate the transaction. However, in UPLC here, since everything says off node, if you just provide the TSN inline datum like this, the node, the Rust code base will not understand what is the datum you're providing. So you have to be a little bit mindful on what information the Rust code base is missing in order to evaluate your transaction. And then you have to provide the extra input like this. So we have this input for evaluation to for you to supply any missing information. For example, here, we try to unlock from a script. And we know that inline datum is definitely missing from the Rust code base. So that's why we have to supply this whole UTXO, because from this UTXO, we know that there's a Plutus data. If we ever try to fetch it from a provider for Mesh, we will definitely find it because it's inline datum, and we could pass it directly. And then from here, we just supply the extra input UTXO for the Rust code base, and then you could perform the redeemer evaluation.
So is there an order of how we should put it here? For example, if we want to spend two different validator UTXOs, then how do I put in those two different?
So you could just put it in any order you want, but there's something that orders matters. Like for example, here we want to unlock from one script. So first of all, you have to go with an indicator of what version of scripts that you're spending from. So this is something that we will always recommend to have stay in the order of script version, TSN, and then just these three is up to the user. But for this thing, since these 5 flag usually comes together, this is something that we would recommend to keep in the same order. So if you want to spend another input, you could just literally just do this. Or you could just shuffle this one above or below. As long as these 5 order internally is the same, it is okay. Like you could also just specify the transaction change address here is perfectly fine, as long as something like Plutus maintain or spending, you are keeping in the same order itself. Then yeah, it is perfectly okay. Yeah.
But when I'm passing the input for evaluation, for two different spending scripts, I have to pass in two different input for evaluation, right? Or is it not?
Yep. Whatever inputs that you are trying to do the off-node evaluation, you better provide that. However, there's some cases that you don't have to do so. Is that if you do the for example, here you're providing the script itself. Like if you do this no, if you are providing the datum for datum hash, you don't have to do so, because the transaction itself understand what is the datum. So that's why I just say you have to be mindful of what's the information missing from the Rust code base. So similarly, if you want to do a reference script like this, but not providing the script, you have to actually provide the input for this UTXO, because this is the UTXO is actually storing the script. And if you're doing, when you're performing the Redeemer evaluation, your Rust code base do not know what is a script, so it cannot evaluate for you. Yeah. So the just provide everything, anything that's missing. So usually just the two different sources that is missing. First is about the datum, another is about the script. You just have to think about if you're missing this thing, then just call this input for evaluation. Get it from, for example, a mesh provider, directly plug it into here. Exactly the same type. Don't have to even do the conversion. Yeah. So if there's no problem, I just proceed with unlocking the fund here. So about what the function is doing, it has some magic. So the simple magic is try to fetch the address UTXO from the script address, and then to check to select the input that is actually putting our own pub key hash as a datum to isolate the script inputs. So this is a way that we're providing the script inputs. Redeemer, same, we are following the JSON data type on mesh to build it. And then some the script types of this is something that we could refer to here. Here we know that we are taking this provider script source as a type. However, if you want to build the kind of post request body, how could you do it? You just have to check what is the flag of it. You know, the keyboard, the language version. Then there's a flag called rename to camel case. So just put this thing into camel case, and that's it. But one thing have to be careful is for this language version is also renamed into camel case. So that's why the v2 here is in lowercase. Right now, I didn't really do any US improvement to make it kind of lowercase, uppercase compatible. But for now, it is required to be lowercase v2. It's okay that you forgot about this. Like, for example, if you put a uppercase on v2, if you try to build the transaction, it will be a error message throwing out saying the v2 is not expected. So you know directly here is this the problem causing the functions throwing errors. So let's try that. Yep. So we could check a little bit onto what is it. You can see the redeemer is actually updated, despite we just put in the 0 redeemer here. So this is a metric performed by the UPLC by TS pipe. Yeah, we specify a 0 budget here, but it's updated over there. And one thing I could also highlight a little bit is that we are adhering to the suggestion from OpEOS is to always add a 10% buffer from the redeemer. Similar to Mesh, we also do the same thing. Yeah, but if you want to update the buffer I remember something here. Yeah, you could just reassign into, for example, 20% of the buffer, 50% of the buffer, or you just trust WPLC entirely. You could just make it 100%, exactly the same as the node suggested. But for default, we just use add a 10% of a buffer. Yeah, so this is a way to unlock from a script. Yeah, any questions on this? Cool. Then maybe just very quickly also walk through minting token. Minting token is somewhat also very similar. As we supply these 4 flat exactly the same. Since here I don't have any inline datum and I'm providing the script itself, so we don't have to provide the inputs for evaluation from here. We just directly throw in everything and it could perform the redeemer updates. So for here, when we're using the mint tokens, we are just literally having a always assist scripts for simplicity. So I just randomly put in a JSON type of byte string as a redeemer, because this is whatever it will work, and then we just mint a empty token name, policy token. Yeah, let's take a look. Same. If we look into the redeemer, it is automatically updated at a 10% buffer. Yeah, and it works. So I think this conclude how we could kind of easier in a use Whisky in an easiest way. So yeah, let's see if any further questions before we go.
Yeah, I guess it is a wonderful session for me at least. Yeah, thank you, Vincent.
Yeah. So yeah, if you like it, just please give it a try. It is also an easier ways for us to expose any things that we have missed implementing. But so far, the test coverage is really wide for this package, because literally for first of all, there are some unit tests around some critical functions here. And second of all, for whatever a version bump, we actually just locally connected with the Delta DeFi transaction repo, like our DeFi project repo. Like we also run all the transactions that we're building in our DeFi project to see if it's anything breaks. So actually it's kind of widely tested before we push any changes here. And yeah, for the example, same, you could just clone this repo, just check how I just link up everything here. It should be pretty easy to understand. Like this is just a very simple way for connecting SEO instance into the web server, how to build the type, how to provide the UTXO just by getting the UTXO from Mesh. And then if you want to use Whisky, what is the easiest way to spin up a web server? This is also a demo. And there's also some basic error handling. Like everything in Whisky, we are returning a result type of when with the error of JS error. Why we use this JS error is actually the error type returned by cardano-serialization library, so that we could just use this question mark everywhere to just unwrap it. Like this question mark literally just meant if it's okay, just return the thing. If it's not okay, just throwing this error to here. And it's just a wrapper of a string. So I think in the repository here, we have quite a lot of different demos on how to use different things. And if you like it, try and enjoy. So I think that's that's all from me today. I think we could stop the recording.